Alright everybody, let's look at number 4. Let's look at this fact. Living things contain two kinds of carbon, carbon-12 and carbon-14. When a person dies, carbon-12 stays constant, but carbon-14 decays. In fact, carbon-14 is said to have a half-life of 5,730 years. This change in the amount of carbon-14 makes it possible to calculate when the organism died. So just to note, like, the idea of the half-life is, let's say that the initial amount A0 is 1, and then this is t equals 0, and t equals when t equals 5,730, then the amount A is going to be 1/2. And another 5,730 years, the amount is going to be half of that, so then that's going to be 1/4. And so you're going to keep taking half of the original amount every 5,730 years. And so what we want to look at is, in number 4, traces of burned wood along with ancient stone tools in an archaeological dig in Chile were found to contain approximately 1.67% of the original amount of carbon-14. If the half-life of carbon-14 is 5,730 years, approximately when was the tree cut and burned? So the root of the question is to find how many years was the tree cut and burned. But in order to do that, we need to know what the decay rate is. So we know that the equation we'll use is A of t equals A0 times e to the kt. And what we know is, in 5,730 years, the original amount is half that amount. So this means we'll have 1/2 A0 equals A0 e to the k times 5,730. Solving for k, we divide both sides by A0, so we're left with 1/2 equals e to the k times 5,730. We'll natural log both sides. The k times 5,730 comes down as a factor. Natural log of e is 1, and so we can then divide both sides by 5,730. K is going to equal natural log of 1/2 divided by 5,730. And so if we put this in our calculator, we're going to see that it's given to us in exponential and scientific notation. So it was like negative 1.24 times negative 1.21 times 10 to the negative 4. So this means it's about negative 0.0012. And I didn't even write a lot of decimals. This is not as an exact form as we would like. So in this case, I think it's going to be to our advantage to use the exact form so that we can get a better number for RT. And so what our equation will look like is A of t equals A0 times e to the natural log 1/2 divided by 5,730 times RT. And so we can leave it like this, but if you recall in one of the other videos, we were able to simplify this. So let's proceed to do that again. We'll have A0 times e to the t divided by 5,730 natural log 1/2. And then the t over 5,730 can be written as a factor. No, it already is the factor. Sorry, it can be written as that exponent. So t over 5, 7, 3, 0, 0. And so the e to the ln base e of 1/2 simplifies to a naught times 1/2, and this 1/2 needs to be in parentheses, to the t over 5,730. Alright, so this is still just one way that we can approach this. We could still use this number here. We can just write more decimals out, but so you have lots of options. So this is our equation that we can now play with to answer our next question, the question that was meant to be answered. So we're trying to figure out if the wood in Chile contained approximately 1.67% of the original amount of carbon-14. We want to know approximately when was the tree cut and burned. So this 1.67% is of the original amount. So what we're going to have is our function is a of t equals a naught times 1/2 to the t over 5,730. And what we have is that it's 1.67% of the original amount. So then this means changing this to a decimal, we'll have 0.0167 a naught equals a naught times our 1/2 t to the 5,730. And so we're going to solve for t. We're going to divide both sides by a naught. So essentially they're gone. And we can natural log both sides. So we'll have ln of 0.0167 equals natural log of 1/2 t to the t divided by 5,730. The t to the 5,730 comes down as a factor. And we'll be able to solve for t from here. So I went ahead and solved for t. We were left off here, and so you would multiply both sides by 5,730, and then you would divide both sides by natural log of 1/2. Plugging this into our calculator, we'll end up with 33,830 years. Chile had this this wood burned, this ancient stone tools. Traces of burned wood along with ancient stone tools are going to be around 33,830 years old. Sheesh. Alright, so just to summarize and recap this problem, it's always tempting to go straight to the question and start to answer it, but because of the nature of these problems, we have to know what K is. We need to know, in this case, the decay rate, or the half-life for the decay rate. And so once you find that, you can proceed to answer the question. Alright, I'll see you in the next video.